Hi students, this is Dr. Knapp, and I noticed as I was going through some of your guided notes that I saw some potential places where there might be some confusion when you came to some quizzes. So I wanted to talk to you a little bit about the saturated fatty acids. So this is in chapter 13. So if you look in the middle of the screen here, we have the two kinds of bonds that can happen for a double bond. So a trans bond has a double bond between two carbons, and then there is a carbon that is going up on one side and a carbon that is coming down on the other. And usually that carbon has an H bonded to it, and then there's other stuff. So the R just means the rest, the other stuff that's there. And so that's why those are there. And then in the opposite directions are the hydrogens. So it's trans because the hydrogens are opposite each other, or we could say the carbon chain is opposite each other. So the carbon chain goes from this carbon to this carbon to this carbon to this carbon. On the cis molecule over here, we still have that double bond, but now both hydrogens are pointed up. And while usually molecules can kind of move around and are sort of floppy, when we have a double bond, that keeps the molecule from rotating. So these two positions can't really rotate around. And so these are not interchangeable isomers. They're different from one another. So most of you were able to identify that on a structure that looked something like this. But usually when we draw fatty acids, because they are such big molecules, we don't draw out the entire molecule with all of the letters in place. So if you look at this zigzag line up here, this is more typically what you will see. So you don't see any letters on this at all. So for organic chemistry, this is what's called a line structure. And if you go back to chapter 11, they'll describe this a little bit. But every time there is a corner, like in these middle places here, or at the very ends where there's no letter, that means there's a carbon. So this molecule has 1, 2, 3, 4, 5, 6, 7 carbons. Now, carbon will always bond to 4 things rather. So each of these carbons where it is not bonded by one of these black lines, all of the other bonds are to hydrogens. So the one that I'm resting on right now is at the end. It has 1 bond to a carbon, so it is bonded to 3 hydrogens. This carbon has 2 bonds to carbons, and it has 2 hydrogens. Same with this one here, so there are 2 invisible hydrogens there. So that's kind of what we see when we see a long chain. Now, when we have this as part of a fatty acid, and I did forget to put in a couple of things here. We have some oxygens that need to go in on our fatty acids here. All right, so when we have a fatty acid, we have one end of the molecule that has 2 oxygens. And when you were drawing your functional groups for your homework assignment, both oxygens and this carbon in between, that corner that doesn't have a letter, all of that is the functional group. And there should be a hydrogen here. So let me fix that really quick. A hydrogen in there. And so this is our fatty acid, and we have another fatty acid over here. And then we see the carbon chain coming out to the side of them. Now, for most fatty acids, this is going to be quite long. So this carbon chain would extend for 16 to 20, maybe 22 carbons coming out here. I've just drawn a short chain because Zoom does not make it easy for me to draw them here. But what I've shown here is how trans is illustrated different from cis. And what I'm going to try and point out is where this comes from. So when you see a trans fatty acid, you're going to notice that this zigzag line keeps its same basic shape. It's going to keep going up and down and up and down. And that's because if we look at this molecule up here and we get rid of the hydrogens, because remember on our line structure, we're not showing the hydrogen. We're going to get rid of this. Oops, leave that one there. Get rid of this hydrogen as well. We can see that we still kind of have that zigzag shape going on here. Whereas with the other molecule, oops, over here, we're going to have more of a trapezoid shape down here. We've got a little plateau coming up. So let me remove the hydrogens here as it would appear in the line structure. And so you can kind of see how this has more of a trapezoid shape in here. So we're going to see a trapezoid shape in the cis fatty acids because of the way that the carbon chains, in this case, are both pointing down. Now, the other option would be for the plateau to be at the bottom and to have both of the carbon extensions being up. But with the trans, we're going to keep that same zigzag shape that we have for the saturated fatty acid. All right, so I'm going to switch how I'm sharing now and show you an illustration from longer fatty acids. All right, so this top picture here, this is a this is oleic acid. And this is transoleic acid. So you can see that the zigzag line doesn't really change at all other than we have a double line here. Now I've moved the carboxylic acid to the other side. That doesn't matter, it can be on either side. But we have that zigzag line not changed. So this is going to be our trans molecule. And then here are two different illustrations of the cis molecule. So you can see that we have the sort of trapezoid shape kind of tilted to the side here in this molecule, and same here. And because this single bonded area can move around a lot, either of these arrangements of the other one are fine. But what you're looking for cis is that trapezoid shape right around the double bond there. So you'll notice that we have numbers on this one. And you'll sometimes hear fatty acids referred to as omega-6 and omega-9. So this comes from a way of counting the carbons. So if we start counting with the carbon where the two oxygens are attached, that's our first carbon. We're going to call that the alpha end, which is the first letter of the Greek alphabet. So it's like the A end. And the other end is like the Z end. Well, the last letter of the Greek alphabet is omega. So if we start counting at the omega end, we're going to get different numbers. But the way this is numbered here, it's counting from the alpha end. So when we get to this 9 here, that is the 9th carbon. And then this 12 is the 12th carbon, 15th and 18th carbon. So if I count back in the other direction, I have 1, 2, 3. The 3rd carbon has a double bond. So that's omega-3. And then 1, 2, 3, omega-6. And another 1, 2, 3 gives me omega-9. And so it turns out that health-wise, omega-3, 6, and 9 fatty acids, cis fatty acids, tend to be particularly healthy. So that's why sometimes you will hear particular foods or sometimes vitamins advertising that they have these omega-6 or omega-3 fatty acids because they tend to be pretty healthy. All right, so that was the main thing that I wanted to share with regards to fatty acids. So when you see questions about, is this a cis fatty acid or a trans fatty acid, I'm apt to use the line structures like you just saw on that last screen, rather than having all of the carbons drawn out, just because there would be so many carbons, it would be hard to see. So I want you to be prepared for that, particularly going into the final exam.